Okay. So I'm going to look at basic and inbuilt functions in R. So let's look at some of the inbuilt functions in R. All right, so my screen is actually shared now. So this is what we are going to look at today. You know, there are functions that you can write yourself, but there are also functions that are inbuilt, which means they are found within the R environment. They come with R. So these are the various functions we want to look at. There are quite a number of them. We're not going to look at many of them. Just want to look at maybe the first 20 or something, and those that are often used. Okay, so let me go straight to the point. So what I have here, I have absolute. I have dimensions, I have structure, I have summary, I have head, I have tail, I have plot, and then whatsoever. So these are summaries. There are also functions that R has already built in and is part of the environment. So instead of you like sum, mean, median, mode, whatsoever, they are all functions that are built in R. So I'm going to be doing that pretty soon. And as you can see, there are quite a number of them. So let me quickly start with dimensions and then whatsoever. So if you have, let's say, I'm going to come here because absolute, I'll be looking at absolute very soon. If I have here, so the structure, if you have something like dimensions and you want to look at it, you want to look at maybe if you have a data frame. So you want to look at the dimensions. The dimension simply tells you how many columns are there, how many rows are there. If you don't have that idea, you may not know the structure of whatsoever, or you may not know how the data frame is looking like and whatsoever. So let's say I'm going to build a data frame that I have. I think I have one data frame called DFF. I don't know whether. Okay, I have some data frame that are here. I'm just going to pick one. But since I am dealing with inbuilt functions in R, why don't I just build in one? I can just, in R, some of the functions that we are talking about before I can talk about dimensions, there are some functions that you can actually, I can just illustrate for you to see. For instance, if you see anything, let's say, and it is enclosed like this, it means that you are looking for almost everything about it. All right. So let's say if I do something like library, and then I just leave it like this and I run it, R is going to give me a whole lot of libraries that are here that I have on my listen. So it's also a function in R. So if you want to know the libraries that are there, the things I have, the packages I have installed, I have library. Library simply means loading it into your R environment. When you do that, you simply have it. So that's also a function. I can actually do, let's say, data, and then I'm just going to. So you see that the data has come. So I want to find out what the kind of data set that I found within R. There are a lot of them. You can see these are data sets that are found within R. It's also a function that we can actually use to be able to find out what data sets are found within R. You just run it, and then another one is here. I could actually say, let's say, package. Let's say I have, or I've been spell it well, packages. Okay. So let's say I have a package this way, and I'm going to just add this to it and then run. I'm sure I didn't get it right. That is why. But if I should get it right, I think that I should be able to packages. It should have come. All right. So, but you have the idea as to how to be able to get, for instance, when I take packages out, I can just put the plot. And then I have the plot there. Let me run it and see. And that's one, two, it doesn't. But the simple basic thing I want you to know is that when you put something like it, it tells you that I want to know the category that I found within that particular function. So now that we did the data and we're able to see quite a number of them, yeah, you see that there's a lot of data that is here. So there's one here called BOD, or there's one called carbon dioxide. So I'm going to use that one. One of that, all that we have here, there are, data sets that are there. So it's actually come with the function or with the package called datasets. If you install this particular function, you have all of them been there. You just install it and load it into the R environment, then you have it. So let's get back to to the studio. And so as a result, I'm going to load one of the data sets. I'm just going to say data, and then uh, into bracket, I'm just going to write the BOD. I'm not too sure if I'm going to, well, it is there. So what I'm going to do is that the BOD is actually the data set. Okay. So let's say that I want to know the dimensions of so the dimensions, I'll just do like this, like dim. And then if I do enter, I just put the BOD like this. What is enough? So it tells me the dimensions. There are about 6 rows and 2 columns inside there. So if you actually want to see it, you can actually do something like head. I can just do head, and then I'm going to put BOD. That's the name of the data set, which is already here. If I run that, you can see that the head means I want the first, is it 6 or 10 that is going to come there. So there are instances I just want the head, but I want the head, and I think I should be, let's say I want the head, but this time I just want the first 3 lines. So I have my head there. So the data set is BOD. I'm just going to do this comma. So if I add 3, it means I want just the first 3 rows, and that's all. So I do that, it's going to print just the first 3 rows for me. The same way, if I want to know the last rows, the last 10 rows, I could actually say tail. Tail is also a function. I just put it like this, and then you put it into bracket, and then maybe I want the last 3 rows. So if I do like this, I just run it. See that it's going to give me the last 3 rows, and then that's simple. So if I want the other function that I've written it here is the structure. You want to know the structure of the data. So if I come down here, I can actually say structure. This is the syntax for it. STR, it means structure. So the structure of the BOD data, I can actually do that. And it's going to give me the structure. This is how it's a data frame. So, a data frame is made of rows and columns, with column headers. You could have row names if you wish. So that's it. The structure, that one, it doesn't have much of the syntax where you are supposed to, maybe add some other argument. The next thing we want to do is we have something called summary. So with the summary, you want to just look at the summary mostly or the 5-point summary. So the summary, we always just put it this way, the entire word summary. And when it comes, I'll just put into brackets the BOD. And then if I run that, it's going to give me the summary. So you can see that the minimum time was 1. The maximum time is there. The mean, the median, and of course, if you also go to the demand, you can also see something there. So I've already talked about head and then tail. That's the summary. So if I wanted to look at how it looks like, I could just come to plot, and then I just do like something like plot, and I'm going to do BOG. This is going to give me a graphical view of it. So let me zoom it out, and you can see that, yeah, it has given me the plot, the demand against time. So you can see that when at this particular time, 1 hour, this was the demand, 2 hours, this was the demand, and in the order. So 3 hours, there was a lot of demand as compared to, among all the time, 3 hours had higher demand. I'm not going to be doing data interpretation. It's the whole topic I'm going to be doing when we are doing data visualization. These are some of the inbuilt functions in R that you can always, rely on. There are quite a number of them. There are some, let's say, I have something like Glimpse, but some of them, they come with their own packages. Just give me a minute. I'll be I just want to okay. Sorry about that. Okay, so some of them, they come with their own packages, and that's why maybe you may, what is it, if you don't have the package installed or loaded into the R environment, you may not be able to. There's a package called Glimpse. There's a function called Glimpse. You see that when I'm typing and it's not coming, it means that it's not been loaded. All right, so those are the few what is it, inbuilt functions. We just look at the library, we look at data, we look at the data itself. Then we look at dimensions. That will tell you how many rows and columns. We look at the head. You want to print the first 10 or 6 rows. And then the last, you can actually specify how many rows you want to print the first or second. So you also have something like structure. You have something like summary. It gives you the 5-point summary. What is it? Which is, and then the plot. It also gives us, some information, or a graphical summary of it. Now, there are other functions that are also there. There's one called absolute. The absolute is what you actually, if you have a data set that is made of, let's say, negative and positives, and you can actually use absolute and then to print only them without the negative numbers. Like I have one here. So the absolute, the syntax is ABS. So you can now just find, this is the vector I've built with this and this and this. So you can see that if I should print the absolute numbers, you see that the negatives are no longer there. You can see it, I have it here. So if I have, let's say, if I want a square root, let's say the next inbuilt function I want to do is square root. So let's say I have a vector called, what is it? 3, and I'm just going to build that vector quite quickly. And let's say I have a C, I want to use so I have 3, this. All right. So if I run this, I actually find the square root of each of them. So if I say the square root like this, okay, what is it? I have a warning sign. A warning doesn't mean it means it's not. That's not the best way to do it. Yeah. So I have my what is it? My vector, which is here. So I decided to find the square of x, even though it retains the, what is it? Then here, you will see that there's a warning sign. So perhaps maybe let me give it just one figure. Let's say I have 88. Let's say 88 like this. Just going to run that, and then you simply, okay. I'm sorry about that. I could actually have left that. I could have left it that way. I just come here. I was having let's say, so I just ran it, and then you needed to print the square root of all of them. So you just do sqrt, that's the square root, and it's actually x33 this way. So let me build the square root, and you see that the square root, what it will tell me what it is. I'm not too sure of the figure I got here. Okay, there is a syntax issue here. Okay, you cannot end your code with an operational sign. So now when I do that, you see that the square root of each of them is actually given. Now the next thing, there's a difference between a square root and then maybe finding the square root of something or something. Okay, or finding the square of something. You could actually do it for a vector. You could do it for a single number. Now the next function I want us to look at is what we call ceiling. Ceiling is also like run up or run down. You have a lot of numbers. Let's say if I have something like this, like 4.5, let me actually build a vector around it, and you see what that means. So let's say I have this, and I have, let's say, 4.3, this 5 point with this 9, 4.6, and in that order. So this actually 5.01. So now, if I do something like ceiling, I'm going to print the entire vector again. But what I intend to do is that if this place is 4.1, it should print just 4. But if this place is 8.9, it should print 9. So it's going to print single values. But it's like it's going to run all of them into whole numbers. You see? So that's it. Now, if I print ceiling, it's going to print all of them absolute. I think I was using X3. So let me print that again and you see something. Yeah, you see all of them. So for the 8, it's going to print only 9. And that's what that means. So the next one, the opposite of that is floor. Floor means it's going to print only the lower ones. It's going to leave everything up. So for instance, I have 2.5. If I want the floor, it's going to print only 2. So I need to print this one first over here. And when I come here, X4, and I want to print, it's going to print only 2, as you can see it in the console here. Down there, it's going to print just 2. So, so round, there are instances we always say that, you come out with your num, and there's a lot of, what is it, decimal numbers, plenty, especially if we're dealing with logs. I'm going to talk about log quite soon. So let's say I have this particular vector that is made of, and that's x6 here. So I have 3 point this, 5 point this, and this. So I want to round them to a whole number. You can actually use the round function. You just round to 2 decimal places. So you put the data set first, the number of decimal places, you add it, and that's it. So now so you see that it is 2 decimal places. Actually, if I don't want it to just return only integers, then I won't put anything there, and it will return only integers, as you can see down here. So then log, those who are mathematicians, they know that there are instances we want a log of, sometimes you are dealing with a set of numbers, and you need to do some kind of data manipulation to be able to get to whatever that you want to do. So sometimes you have to take a log, anti-log of something. So I have a vector here that I have built. All right, so that's my X7 there, and I want the log of it. So if I don't add anything to it, it means I'm taking log 10 of each of them. So in that case, it's going to return. So if I take log 10 of each of them, it's going to return this particular number, and that are the log 10. So I have here exponent. Exponent means something raised to the power 2, right? Or raised to the power. So let's say I have this. So it's equals to 4, and then I want the exponent of, I'm looking for an exponent of 8. Yeah, so the exponent of 8 is going to give me 54 point something, and that's it. So the next one we are going to look at is substrings. Substring. This part is quite very important. These are inbuilt functions I'm just showing you. I don't want to bore your time. That's why I wrote them down before. So this is a substring. Now you have a data set like this. All right. So if you have this data set, it's inside A. A is now the data set here. And you want to print the data set, let's say, from one position to the other. What you do, that's what we call a substring. You see, we call it a substring, and then it can actually print. So we are going to print from position 7. So position 7 is 1, 2, 3. So from the 3rd position up to the 3rd position, it means we are going to print only one. We're going to print just one item. So you see that if I run this, if I run this, if I have a string, I want to and then I decide to print the subset. You see that's going to print only 7, and you can see 7 down here. So supposing I wanted to print up to the last figure, you see that from 3, it will be 1, 2, 3, 4, 5, 6, 7. So I would have changed this place to 7. And then in that case, when I run, it's going to print the last one. That's how we actually print a substring. You can actually repeat this in several ways. Let's say that I have BB, and then I just want to maybe I just have a string like this. This is how we create a string. So and the string is just full of, let's say, uh, uh, what is it? A lot of things inside there. And then I just want to print from a particular position. I want just sub of that one. All you need is to know that particular position. So you first of all, I have to run it. And then in that case, when I come here, I can actually do a sub string, and then it will even come by itself. Then I'm going to say AA, and then from which position? The first one is the position, which is going to be, let's say I want to print from 5 um, all the way up to let's say 9. So I want to print that particular string. So do that is going to print that for me. And that is it. So substrings are very important. We'll get to know. So the other one is replacement, substitution, like we will do in mathematics. You have a lot of things, a sentence, or you have a sentence constructed, and you want to replace a particular word. Imagine that, in Excel, we easily do something we call find and replace. But in R, what we do is we do something we call substitution. When you have a whole string, and you want to replace one word there, you can actually replace the word. For instance, I have here, England is a beautiful, but no, the part of but not the part of EU. I think I didn't write this well. You see, so I want to, replace England with UK. So first of all, that's the string here I have here. So I want to replace this particular word. So first of all, you use the sub. So which word are you substituting? England with what? UK. And it is found where? It is found in this particular data set. That's why it is. So if I run that, the new one, when I print it, you see that it's now UK. That's how it is. I can actually print a different one and you see. For instance, let's say I have a data called, like, what is it? BV. And then I just decided to maybe do, let's say, have a string, a whole string, okay? And then let me just do that and say, okay. Okay. I'm just going to say that Kumasi is the capital of Ghana, right? Then I've written this a whole document. Later on, I realized that no, I've made a mistake. I need to change Kumasi. How am I going to go through the document one by one before I'll be able to do that? So all you need to do is to come and then you have your substring. You just say that you want to do your substitute. And what are you substituting? I am substituting Kumasi for, and then you come out for what? I'm substituting Kumasi for what is it? Accra. So, and then where is that particular data set found? It is found in BV. And so I'll just put the BV. That's all. So do that when you run this. If I now come and run this, you see that the information is now Accra. It's no longer Kumasi. That's how it is. That's how we use substitution. The other one is something we call what is structure split. It's a function, inbuilt function in R, structure split. Very, very important. What do we do? You have a lot of, there are instances I want to build, let's say, what is it? A vector of words or people names, and typing it is always a problem. You can actually use something we call structure split to be able to do that. I just have one here. So if I run it like this, if I want to come and split it, it's going to split each of them as an individual, let's say, string, individual string. It will split the words into strings. And that's what that means. So and that's all. You see that it has splitted every single letter as a string. If I don't want it that way, I could have actually come here, this place, just open up the space more. And then if I run it again, it will not split it into words. Now, this is the difference. Let's say that I have this vector dd. I have that particular vector, and then I'm sorry about that, and then I want to have a lot of people's names, or I'm building a data set of too many people's names. Always come and do the typing is always difficult. But if, let's say, I just want to say the first name is what is it? Bigba. I'm not going to add anything. I'm just going to the second name is Bright. No, there's no comma. The other name is, let's say, Dude. Other name is what is it? Let's say online. I need to put all of them as a string. That is why R is giving me a warning. Let me come and close it up. Especially when I'm writing code, I don't really like seeing. So the other name is Ama. The other name is, let's say Kuma. The other name is, let's say, Aaron. The other name is, let's say, Big, in that order. So later on, I want them to come. I want to form what is it? A data frame of names of people. So I just type everything like that, and after that, when I run, it runs all right. After that, I have to use a split or a structure split. So which we say a structure split. You won't even finish, and that comes there. So the structure split, I am actually going to split this particular data set called DD. And then you do like this. And then when you do the double quote, if you leave it like this, it's going to split each of them by letters. But when you widen the double quote by one space, it means you want it to split into words. So each word will come. So for now, if I leave it this way and I run, it's going to split everything into one single letters. But now, if I come here and then I open up the space more, it means I want each name to come absolutely. So what I can do is just do like that. You see that now the names are now absolute. So if I have done that, I could have copied this one into something. So that's how it is. So I have quite a number of the split strings I have here. Okay. So the other one is like you change something into a lower case and you change something into an uppercase and whatsoever. Let's say I was saying that I have something like here. Just say what the Libra is the tutor for basics of data science. All right, that's a whole string, but I want it to be in a lower case. Okay, so you just to lower and then you put the name of the what is it, the data set. So you just run this, and then when I run to lower, then it's going to be ESL. If I run that, it's going to give me there's an error somewhere. There's no problem. Let me run it again. TS1. It's actually not F, it's 1. I'm sure. All right, so you see that now Diba is the tutor for basics of data science. All right, so that's how it is. We could actually combine some of these functions to be able to give us whatever that we want. These small functions are very important for some reasons, which I will be. There are other inbuilt functions like the mode, the median, and then the statistical packages like the binomial distribution, the Poisson distribution, with the quantiles, then the first quantile, the second quantile, and all those things. They are all inbuilt inside. All right. So we'll be looking at them as and when it becomes necessary. So this part one of inbuilt functions. I'll come out with the part two. We're going to be looking at statistical inbuilt functions, probability, and then what is it? A probability distribution, I mean. And then you will see how that also works. So that has been your tutorial for tonight. Thanks very much for being around. You can actually explore more of what we have done today. But by way of summary, this is what we have done. You just can look at your dimensions, look at your data, can do a lot of things here. So thank you. Thank you very much. Hope you've learned something. I'll see you tomorrow. Bye-bye.